Hello learners, and welcome to today's lesson of Interpreting Graphs, where we are going to focus on the practice and application questions. Let's get to our lesson. So the first one, or the first question that we have there says, for each of the following graphs, state whether they are linear or non-linear. Now remember, when we are talking about linear graphs, we are talking about graphs that are straight. If you can remember, these can either be horizontally straight, vertically straight, or diagonally straight. And of course, when we are talking about non-linear graphs, we are talking about graphs that are not straight. Of course, these can include graphs that are curved. So let's look if we can see whether these graphs are linear or non-linear. The first graph that we have been given there, is it straight or is it curved? Of course, we can see that it is a a linear graph because it is straight, as we can see. What about the next one? Is it linear or non-linear? Yes, this one is non-linear because it is curved. It is not straight. What about the next graph that we have been given there? Is it linear or is it non-linear? If you are thinking non-linear, then you are absolutely correct because we can see there that it is a curve and it is not straight. So with the graphs that we were given here, the first one we should have written there is of course a linear graph. The second one is a non-linear graph. And of course, the third one there is also a non-linear graph. Let's look at the next graph. Is it linear or is it non-linear? Yes, you are correct. We can see that it is not straight, which means that it is a non-linear graph. It is curved. And what about the next graph that we have been given? Is it linear or is it non-linear? Yes, you are correct. It is a linear graph. And why is it a linear graph? Because it is a straight graph. And that is our linear and non-linear graphs. What about when it comes to constant, increasing, or decreasing? It says therefore each of the following graphs state whether they are constant, increasing, or decreasing. Now, if you can remember, when we are talking about our constant graph, we are talking about those graphs that when our horizontal values are increasing, our vertical values remain the same. What about our increasing graphs? Now, our increasing graphs, we are talking about when our horizontal values are increasing, our vertical values are also increasing. Lastly, when we are thinking about our decreasing graphs, we know that as our horizontal values are increasing, then our vertical values are decreasing. Let's look at the following graphs and see if we can see what type of graphs they are. So the first one there again, we can see that when we are increasing in our horizontal values, then what is happening to our graph with the vertical values? Well, those vertical values are increasing. As we can see, we are increasing there. So this means that this graph is an increasing graph. What about our next graph? Well, our next graph here, we can see that as we are increasing in our horizontal value, what is happening to our vertical values? Well, those values start by decreasing and they get to a point where they start increasing. So this graph would be both an increasing and a decreasing, but depending on where you are on the graph. So when we are looking at the first part of our graph, we can say that this part is decreasing. And why are we saying that it's decreasing? It is because our vertical values are going down as our horizontal values are going up. And then what happens when it gets to this point where it turns? Then we can see that it starts increasing. So we can see that our graph starts off with decreasing and then it increases. Let's look at the next graph there. The next graph there, we can see that as we are increasing in our horizontal values, what is happening to our vertical values? Yes, they are decreasing. So that is an example of a decreasing graph. Let's move over to our third practice question here. So it says there, the graph below represents the number of cars sold recorded at the end of each month for 6 months. So as we can see our graph there, we have our 6 months represented there, and that is July, August, September, October, November, and December. That is represented on our on our horizontal axis there. And when we are looking at our vertical values there, we can see that those are the number of cars sold. So our question there for A says, identify the minimum number of cars sold. So remember, the minimum refers to the lowest value vertically. So we are going to identify the month that has the minimum number of cars sold. Can you identify that month? Yes, we can see that the minimum or the lowest number of cars sold was that 15 cars. And of course, that belongs to September. So it means that the month with the lowest number of cars sold was indeed September. The next question there, the question for B says, identify the maximum number of cars sold. So the maximum number of cars sold, okay, let's just write the number of cars sold that was a minimum, and that was, of course, 15 cars. And that was sold in September. Sorry for that. So moving on to the question for B, we want the maximum number of cars sold. So can we see the maximum? Remember, the maximum is indeed the highest number of cars sold. So when we are looking at the number of cars sold here, can we identify the highest number? If you are thinking of 45, then you are absolutely correct, because we can see that 45 there is the highest number of cars sold, and those were the cars there in December. So we can see that the maximum number of cars sold there is December, and that was 45 cars that were sold in that month of December. Let's look at our fourth question. Now, our fourth question there says, the graph below or alongside represents the number of ice creams that were sold within a period of 8 days during summer. So we can see there that the number of ice creams sold have been represented on our graph, where the values for the ice cream sold has been represented on the vertical values, and of course the number of days there have been represented with the horizontal values. Let's look at our questions there. It says they identify the maximum number of ice cream sold. Now remember, maximum refers to the highest, so we are going to look for the day with the highest number of ice creams sold. Can you identify that the number of, or the maximum number of ice creams sold? Yes, it is indeed 20 ice creams that were sold there. So we can say there it is 20 ice creams that were sold, and those were sold on the 8th day, or day number 8. What about the minimum number of ice cream sold? Now remember, minimum is the lowest value. So can you identify the lowest number of ice creams sold? Yes, it is that that number of ice creams there, which was on day number 5, and those number of ice creams were 12 of them. So 12 ice creams were the lowest, or the minimum number of ice creams sold, and that was on day number 5. And then question C there says, is this data continuous or discrete? Explain. Now, do we remember what continuous data means? continuous data is that type of data that consists of fractions. And when we're looking at discrete data, that's the type of data that only consists of whole numbers. It's the data that is counted. So when we're looking at the number of ice creams sold, do you know what type of data it is? Well, if you are thinking of discrete, then you are absolutely correct. And the reason for this is that when we are working with the number of ice creams, we are talking about data that can only be counted, data that can only consist of whole numbers, because we cannot say that this person sold 2.5 ice creams. That is not possible. Instead, we sell the ice creams in whole numbers. Let's look at our last practice question there. And it says there, the graph here represents the price of meat per kg at a supermarket. So we are going to be looking at the price of meat per kg. Price is represented vertically, and the meat of kg, or the kg of meat, is represented horizontally. Identify the maximum price of meat on the graph. So if we are looking at the price of the meat of the graph here, we are looking for the highest price, and that highest price would be for purchasing 7 kgs of meat, and we've identified that price there. If we want the exact value, we are going to move along on our graph, and of course you are going to use your ruler to find the price there of meat. And if we were to estimate the price of meat for that highest point, or for that maximum point, then we can say that that can be an estimate of a plus minus 730 rands worth of meat. And that, of course, is an estimate according to our graph. What about the minimum price of this meat? Now, the minimum price, of course, would be the lowest point, and that lowest point is for 1 kg of meat, and we can now estimate that price. It being there, we can say that that meat was perhaps 120 rands of meat. And of course, remember, this is an estimate, so that is plus minus 120 rands for that 1 kg of meat. The last question there for this question says, is this data continuous or discrete? Explain. Well, what type of data is discrete and what type of data is continuous? Remember, discrete can only work with whole numbers, and continuous can have fractions. So when we are looking at the kgs of meat, can they be a fraction, or must they only be whole numbers? Of course, kgs of meat can be fractions, which means that someone can purchase 3.5 kgs of meat, and they will be given that price for that meat. So which means that this data is indeed continuous. And why is it continuous? Continuous, and it is continuous because it can be, or it can consist of, fractions. And because this data is continuous, that means that we can connect these points, because we can have somebody purchasing less than 1 kg of meat. So this means that these points must be connected, because we know that in between the whole numbers, our data can consist of those fractions. Let's quickly go to an ad break, and then we'll see you just now.